Imagine trying to write down the exact mathematical physics equations required to perfectly balance a bicycle as you ride it. You couldn't do it. Your brain doesn't use formulas to keep you upright. You figure out the mechanics through practice, a few scraped knees, and getting a feel for the motion over time. This diagram shows how traditional computers operate. They are essentially extremely fast calculators. You give them a rigid set of if this, then that rules, and they follow those instructions perfectly every single time. That strict obedience is exactly why a standard computer can calculate a massive spreadsheet in a millisecond, but would immediately crash if you asked it to pedal a bike. It relies on exact rules, not intuition. For decades, programmers were trapped by this limitation. If they wanted a machine to perform a task, they had to anticipate every possible scenario and write out the exact instructions by hand. Artificial intelligence solves this problem. Instead of handing a machine a rigid list of commands, we give it the ability to learn from experience. By removing the strict rules, the machine becomes an adaptable student, capable of figuring out the best path forward on its own. But how do you give a computer experience when it doesn't have a physical body to practice with? You feed it data, lots and lots of data. Think about how you teach a toddler to recognize a dog. You don't read them a dog's DNA sequence. You sit with them and you show them picture flashcards of golden retrievers, poodles, and pugs. By feeding a computer millions of pictures, clearly labeled dog or cat, the machine starts to spot the visual differences for itself. It learns through these examples rather than through manual programming. The computer isn't memorizing the specific photos. It looks at the traits, like ear shape or snout length, and calculates a mathematical boundary between the features of a dog and the features of a cat. When you strip away the intimidating terminology, machine learning is simply advanced pattern recognition powered by massive datasets. To process these complex patterns internally, the computer uses a biologically inspired system called a neural network. Picture a neural network as an assembly line. The first layer extracts simple edges from an image. The next layer groups these into shapes, like pointy triangles for ears. Finally, the last layer compiles the evidence and confidently decides it's looking at a cat. This conclusion is actually the result of hundreds of tiny, simple mathematical filters stacked on top of each other. Machines can now do tasks beyond sorting and categorizing existing data. That brings us to generative AI. If traditional machine learning is a student sorting flashcards, generative AI is an artist who has intensely studied millions of historical paintings. This diagram illustrates how large language models work. By scanning massive amounts of text across the internet, the system learns which words are most likely to follow one another in a sentence. Because these models understand the mathematical patterns behind art and language, they don't have to copy past work. They generate completely original outputs on demand. These systems can now use what they've learned to actively create original things within our world. You are already interacting with these distinct systems every single day. Machine learning is the engine tracking your viewing habits, finding the subtle patterns to recommend the perfect movie on your favorite streaming app. Neural networks are breaking down your facial geometry, layer by layer, to securely unlock your smartphone. And generative AI is powering the chatbots that can draft a professional email or summarize a dense document in seconds. Artificial intelligence works as a form of highly advanced pattern recognition, fueled by massive amounts of data and processing power. It is a new kind of student, learning exclusively from the world we choose to show it.